Okay, so we're now going to take our knowledge of redox a little bit further and move on to writing the half equations. Now, I know for a lot of you this jumps straight into fear about electrolysis, but you don't have to write half equations only for electrolysis. So we're going to start nice and simple with doing some half equations for some usual redox reactions, more simple redox reactions, and then hopefully that will get you used to the idea of doing half equations before we get too hung up on all the electrolysis stuff. So we're going to go back to the equation that we looked at in our reactivity video, magnesium reacting with oxygen to make magnesium oxide. And we can use any of our definitions here or either of two of our definitions for redox. The magnesium has gained oxygen, so we know the magnesium must have been oxidized, and the oxygen has been added to something, so it has to have been reduced. We can also think about it in terms of electrons moving, and as we know, magnesium, if it's in an ionic compound, would be Mg2+. It has lost electrons, and the oxygen will have gained electrons. It's O2-. So we've gone from not having a charge to having the charges because electrons are negative. Mg2+ has been oxidized, it has lost electrons, and our O2- has been reduced, it has gained electrons. So with half equations, all we're trying to do is show how we got from this side over here, our magnesium that had all of its electrons, to our magnesium that now has lost 2 electrons. And we must remember our balancing. This is the key bit here. So we have over this side 2 magnesium. So first of all, I think we write our oxidation reaction. So our thing that's oxidized is our magnesium. So we have 2 magnesiums over here, 2 Mg, and we are turning it into 2 Mg2+. Okay, now we are going from a state where all the electrons are on there to electrons having come off. And because the arrow shows the movement of a reaction, the electrons coming off must be after the arrow. They have left the magnesium and come off it. So we would go from 2 Mg to 2 Mg2+, because that's what we've turned into. And we have the electrons that are coming off. So we have lost electrons. Electrons have come out of our magnesium over here and are now by themselves effectively in our half equation. How many electrons do we have? Well, we have 2 Mgs and they are 2+ each, so we must have 4 electrons that have come off. So we would write 4E- there. And that is our oxidation half equation. We have shown the electrons coming off. So then we need to look at our reduction equation, our reduction half equation, and we know it's the oxygen that is being reduced. It has lost its independence, it has gained electrons. So we start off the same as this time. We only have one O2, so we would write O2. And because we are adding electrons on, the electrons are going to come before the arrow. They are being added to the oxygen. So we know we've got to have electrons before our arrow, and then it is becoming our O2-, and there are 2 of them because we've got the big 2 before our magnesium oxide. So we would have 2 O2- that are after the arrow. They have gained the electrons. Now, 2 O2- means there are 4 electrons here, 2 lots of O2, so we would have to put 4E- over here. And that means our equation is correct because we've got 4 electrons coming off of our magnesium and 4 electrons going onto our oxygen. So there's the same amount of electrons, so our reaction must be balanced, it must work. So this is our oxidation equation, and this would be our reduction equation. So in a similar way, you could do this for most reactions. If we have something that's not got oxygen in it, we can still work out where we are. Sodium plus chlorine makes sodium chloride. We know the sodium is going to be losing electrons. We know we're going to have Na+, and we know the chlorine is gaining electrons. So we know we're going to have Cl-. And again, we have to think about the balancing. So we would start with our oxidation equation. Our sodium is a thing being oxidized. So we would have 2Na. Remember, it's important that this top equation is balanced in the first place. We know we are going to lose electrons, so they are going to be after the arrow. We're going to have 2Na+. because we had 2 Na here and it's an Na plus. 2 Na pluses means we must have 2 electrons that have come off as well. And now that we know this is balanced, we know how many electrons we're adding to our chlorine. So for our reduction one, obviously we start with the Cl2 because that's what's there. We know we are being reduced, so we are adding electrons. We know it's going to be 2 electrons because we had 2 electrons come off the sodium, so it would be plus 2E minus. And we end up with 2 Cl minuses because we've got 2 NaCls. And that would be our reduction equation. So remember, these must cancel out and you must have that top equation balanced. For the last one, this is a little bit trickier. In this one, we have 3 elements going on. All the others we've just had 2, which means we need to think a little bit about what has been oxidized and what has been reduced. Now, it's a little bit easier to work out on this one because the carbon has gained an oxygen over here. So we know our carbon must have been oxidized. Okay, so our carbon absolutely must have been oxidized. So our carbon is our oxidized thing, which means either our oxygen or our iron has been reduced. We can work that out as well because FeO, iron oxide, the iron has lost oxygen. It has been reduced. It has lost oxygen. So our Fe must be our reduced thing. Now, how do we work out the charges? Well, we know oxygen gains 2 electrons, and these things have been stuck to 1 oxygen. So we can work out that Fe over here must be Fe2 plus because it's got 1 oxygen attached to it. Oxygen is 2 minus, so it would be Fe2 plus. And that must mean our carbon over here has become carbon 2 plus because it's got 1 oxygen. And this iron is 0 because it's all by itself. So our oxidized equation, we've already said, we know it's our carbon that is oxidized because it has gained the oxygen. So we start with our C. We know it's there. We know it's oxidized. The electrons come after the arrow. And we are making C2 plus 2 electrons because we have gained the oxygen, which is 2 minus, 2 electrons coming off. We can then do our reduced one. We know iron starts off as Fe2 plus. We know we're gaining electrons and we know it's 2 electrons. And that means we are going to make pure iron, Fe. You may wonder what's going on with the oxygen in between here. Well, here the oxygen is O2 minus, so it's O2 minus. Here the oxygen is O2 minus. So actually the oxygen doesn't change from one side of the reaction to the other. And this reaction, this idea that carbon can cause iron to be reduced from its oxide, is going to be very important when we look at both rusting and extraction of iron in the future.